We're going to calculate the capacitance in femtofarads on the output node of an inverter with an external load in a 0.35 micro CMOS process. So again, what we want to find is the capacitance in femtofarads at the output node of our inverter. So this is just something to remember. This is what we're doing for, but it's not necessarily going to be extremely important to the problem. So output node of our inverter. So if we have an inverter, we have like our PMOS and NMOS, and we have this output right here. We're looking for the capacitance right here. Now we have the following variables, and yours might be different, but we're going to talk about general equations that we can use to actually go ahead and solve this. So in step 1, and this is the very important step, we have 3 important steps before we get the entire thing. The first step is to calculate the Cout driver. There's 3 drivers. We have the Cout driver, we have the Cin driver, and then we have a C wire as well. So Cout driver is going to be the following equation. We have this equal to, so I'll actually just write equal to, our Cjn plus Cjp plus 2, and this part's pretty longer but easier to remember, Cjswn times our Wn plus 2 times Cjswp times our Wp. So this is going to be our equation, and we're just going to plug our values into it. Now you can use the values that I have as kind of a template if yours is different, but for our Cjn for this problem, we have I'll write it over here, 0.9, and this is going to be in femtofarads, and then our micrometers squared, plus we just have 1 femtofarad, and then we are going to have plus 2 times, we have our 0.2, that's going to be this right here, so 0.2, it's in femtofarads, and then we have our, I should do a femtofarad like this, femtofarad. Don't forget the micrometers squared on the bottom. So for this problem, we have 0.9 femtofarads over a micrometers squared plus our Cjp, which for this problem is 1 femtofarads micrometers squared plus 2 times our Cjswn, and that's going to be a 0.2. We have femtofarads for this problem. We want this in femtofarads. That's very important right here. So we're not actually going to be changing anything because we're given everything in femtofarads. Now, our Wn and our Wp is actually given in micrometers, but that's okay because it's going to combine with this right here. And we already have the femto, and so that we can add them all together. We then have our, this is going to be, because we're dealing with Wn, we have a 3.1, so we do times 3.1 plus 2 times, we have our Cjswp, it's going to be 0.3, and then our Wp, the Wp is just going to be 3. So this is going to be our entire problem. Plugging into a calculator, for this we get about 4.94. Now part 2, in part 2 we want to solve for our Cin driver. So this is the next one. So the Cin driver is going to be equal to, we have this equation is COX times our Wn times Ln plus COX times Wp times Lp. Now you can easily just add the WLN and the Wp and then just factor out the COX. That could be a little bit easier, but this is just everything expanded. We have 5 femtofarads for this problem being multiplied by 3.1 micrometers. We can see it's going to easily cancel out when we actually put in the 0.35 micrometers for our Ln. We are going to have plus our 5 times 3 and then 0.35 here. That's just plugging in our values. And this is going to give us 10.675, and this is in femtofarads as well. So both of these are in femtofarads. It's important to remember. We don't need to convert anything. And then step 3 would be to find the C wire, but we don't have it here, so it's just going to be 0. And now we are going to add everything together. So step 4, the last step, is going to be that our Cout, the capacitance at the output node, is going to be equal to our step 1, which is the Cout driver, plus number 2, which is the Cin driver, plus number 3, which is our C wire. And for this problem, it's going to give us approximately 15.615, and this is in femtofarads. So farads is how we would measure capacitance. Femto is just 10 to the negative 15. So that's how we would measure this, and that's how we would go about solving for this problem.